Okay, so we have an OR sequence here. We have a 0, then we get a 1. Then we get 2 zeros, then we get a 1. Then a 3 0 and a 1. Then we get a 4 0 and a 1, a 5 0 and a 1. So the stretch of zeros get longer and longer. Right, so as we get further down, we're gonna have a ton of like zero, like infinite, like 1,000 zeros and a 1. Right, 1,001 zeros and a 1. So it just gets longer and longer. Now, does that mean it's actually converging? And we have to look at this definition of convergence. Okay, so it says here, it converges to L if for every epsilon that's greater than 0, there is a corresponding integer n such that we make it bigger than n. It's guaranteed to be for every epsilon, an, right? Every an minus L, the difference between these two, the distance between these two is epsilon. Okay, what that means, it's converging if provided that no matter how big the number may be, or we pick some big number, beyond this point, okay, let's say this epsilon is some small number, and let's say the small number of that thick. Okay, so we can pick an n so that the sequence, the difference between the sequence, and the difference is represented by, okay, this height and this, let's say this is the line right here, this is L. So the difference between the L and this point is actually at most epsilon or smaller. Right? If we can make that happen, then we say it's converging. Now for this function though, right, we can actually make it equal to 0. So we can always make it, smaller than any epsilon, right? No matter what positive epsilon we pick, because for most of the sequence, right, it's just 0. Right? So if you subtract 0 with 0, it's going to be smaller than any positive value. But that has to be true for any number after n. Right? But as we go, we know that even though most of the time it's not there, at some point it's going to be 1. But it has to be for every number after n, and that's not the case. Right? So at some point it's going to be bigger than epsilon if we pick, for example, epsilon to be, let's say, 0.5, right? Which means the difference between the sequence and the 0, the difference must be 0.5. Okay, so this is really going through the delta epsilon definition, the precise definition of limits. But for that reason, we say the limit, the an, actually diverges. It doesn't converge.